Well, thanks very much. Good afternoon, and thank you for being here today, in person or virtually, for the 7th Annual Community Engaged Research Lecture. I'm honored to have the opportunity to offer a few words of welcome and context for today's lecture, and I will be brief because I'm not here the person you're here to hear from. Before beginning, on behalf of Provost James Holloway and all the team in the Office of the Provost, I would like to signal our thanks and appreciation for the work of Vice President for Research Ellen Fisher and her outstanding staff, as well as the Faculty Senate Research and Creative Works Council and the Research Policy Committee in supporting research and creative works at UNM in general, and this award in particular. The first Community Engaged Research Lecture Award was given in 2016. The award was modeled on the UNM Annual Research Lecture Awards, which date back to 1954, but with the distinct goal in this case of giving special recognition for scholars who work in partnership with communities. The award was established to recognize scholars whose work co-creates new academic knowledge in collaboration with communities, and that speaks to community goals and priorities. This award is central to UNM's mission of enhancing the quality of life for the state of New Mexico by strengthening collaborative relationships and promoting initiatives that foster open, public, and civil discussion of matters of public concern among UNM scholars, learners, and the community at large. Community engaged research provides us with an avenue to more effectively and authentically fulfill the university's social responsibility by working alongside communities, understanding their lived experiences, and translating research findings as a way to identify issues and provide empowering solutions. It's the central mission of UNM to create new knowledge and promote learning. At UNM, research is at the heart of our work. Research is education, to steal Ellen's tagline. Students often learn most deeply and are most inspired by doing research and creative works. For many faculty, teaching and interactions with students drive our research questions and strategies. In other words, research and teaching reinforce one another, and successful researchers remain learners throughout their careers. Successful community-engaged researchers approach communities with the expectation that communities and specialized researchers have much to learn from one another. All scholarship at UNM, from basic research into the fundamental aspects of phenomena, to humanities scholarship on the varieties of meaning, expression, and human experience, to artistic creations and performances, to applied or policy research, all of this work promotes the public good. But some of the greatest research at UNM does all of these things at once. It measures and elucidates how things work at a basic level. It engages with what things mean to people. It involves creativity and imagination, and it has direct application to the urgent needs of communities and our society. And these are all qualities that describe the work of this evening's speaker, Dr. Johnny Lewis. I very much look forward to hearing her lecture this evening and to learning more about her work. Here to introduce Dr. Lewis is Dr. Jose Cerrato. Dr. Cerrato is Associate Professor in the Department of Civil, Construction, and Environmental Engineering. He's a scholar of biogeochemical processes that affect the cycle of metals and radionuclides in the environment, with particular attention to water quality. He has collaborated with our speaker, Dr. Lewis, in working on, with Native American communities to better understand biogeochemical processes through which uranium mining wastes interact with the surrounding environment, including water and soil, in order to mitigate harms to those communities. So please join me in welcoming Dr. Jose Cerrato.
Thank you. Thank you very much, Bill. I really appreciate it. So, yate, my friends, you know, a lot of raising the hands, right? Hola, for those of you who are. So I have the honor and happiness to present a very dear friend, mentor, director, leader of this university, my good friend Johnny Lewis, and I will use the storytelling abilities that I have learned from my community friends. So Johnny Lewis is a dual US Canadian citizen. And she has really been inspiring because in this university, a fact is that we have always tried but have had challenges to merge the Lomas Divide. Okay, so that is the health sciences and the main campus. And I cannot think of a better person to have successfully not only overcome this divide, but many other divides. So for instance, for those who are passionate about working with communities, many times we have heard, oh, well, this is not science enough, right? Or this is not fundamental enough. So turns out that we have learned through Johnny's efforts and leadership that it is possible to do great science, community inspired from the needs of our people in New Mexico. And this is a great state, and we are a great university. And I think that on the analogy of the 4 seasons and 4 cycles that we always hear from our native communities, I want to stay with the fact that Johnny's legacy leaves us a lot of hope, right? As she is going from full-time to 0.25% effort or 25% effort, which honestly 25% effort of Johnny's energy is like 200% of any one of us, okay? So, and thankfully here are all of the great funding centers that she has been able to lead at the university. We're very honored today to have Trevor Archer and Carol Blaisdell from NIH. We're honored to have our community members here, many of them I already said hello to. We have a very dear relationship. So I am sure that you will be inspired, Johnny, when you see this amazing audience. And of course, our trainees, who I see many, who inspire us, right? Give us energy to continue. And going back to what Bill just said, and Ellen Fisher says all the time, research is education. I cannot think of a person who can exemplify that mojo more than Johnny Lewis. So please welcome Dr. Johnny Lewis.
I think I got this on. Is this on? Thanks. Well, thank you both for such a great introduction. While he's adjusting that, it is absolutely fabulous to see all of you here today. And no, it's nothing that I'm going to talk about would have been possible without all of your involvement. And it's been really inspiring to be able to get to know all of you and work with you and see you all take the time to come to this meeting. So I will get this under control. I do this every time something good happens. So that's okay. What's up? Okay. Oh, okay. Well, while they do that, I think I can speak again. All of the work that I'm going to talk about today, as I just said, is a result of all of the people in this room, and none of it could happen without the communities that have asked for us to work with them, and without their instruction on what the problems are and what needs to be done, and without their trust and willingness to work with us. And it has been an incredible honor to be able to build this team. And are we, what? This, okay. And I'm gonna, let's see, wait. And of course I have to start backwards when it's not working. There we go. I just want to note that the work that I'm going to talk about has been, we've been really fortunate to have funding from a number of institutes at NIH and to have a number of center level programs that have really helped us to be able to do the work that we're going to talk about. It's been happening since 2000. It actually started somewhat before that. And it all integrates and builds on each other. And so I'm probably going to seamlessly move back and forth between some of the communities and some of the projects. And I wanted to just take a minute at the beginning to go over the background that I brought to this, because to me, this is part of the reason that it's been so successful. I did not come through a standard academic path. My background started with a master's in psychology. Well, it started before that, but my academic background started with a master's in psychology, and then went on to a PhD in pharmacology a number of years later. I've run small businesses, created 2 small businesses, and worked on statistics and modeling for a number of years while I was in Canada. And down here had an environmental consulting group that I ran for a number of years that was working around Los Alamos and with the Accord Pueblos. So from that point moving forward, working a lot with the contamination that was related to the development of the bomb and the impacts on Indigenous communities. And in that process, I also had an opportunity to do a lot of work around policy, work with a lot of federal agencies, work on the land dose reconstruction, and run the community involvement part of that in northern New Mexico, working with a lot of the Accord Pueblos, as well as a lot of the traditional Hispanic communities up there. Have written policy change for uranium standards with the help of a lot of people in the room. And I think all of that background is noticed at the right, enumerated at the right, created to a sense of inclusion in the work that we did, and the need to look at things from many different perspectives. And so hopefully that basis, I'm gonna probably just keep getting confused here. Okay, so when I came to UNM in 1996, one of the things that I started was the Community Environmental Health Program. At the time, it was in internal medicine. It was intended to be part of a center that ended up not getting funded, but the program continued. And the goal of the program really was to try and build effective translation, even though translation wasn't an issue at that point. But we really saw the people working in CEHP as being able to facilitate the kinds of discussions that would be inclusive of all of the people that were involved in making the decisions that could reduce the impact of some of the environmental injustice in the state. And we saw that group to include not only the researchers, but healthcare practitioners, the communities, and the policymakers. And while a lot of these sectors had good communication among each other, the communication through the whole group was pretty minimal. What we found as we started trying to hold these joint meetings was that we couldn't really facilitate a discussion because none of the groups had the same language. And I'm not talking about Navajo versus Spanish versus English, but nobody had even the same basic concepts. And from the work that we had done with each of the groups, we could see people saying the same thing in a room that was not being heard the same by anyone else. And so we kind of backed up and looked at this communication model as a really fundamental piece of trying to keep everybody in the room at the same time to understand their rules, understand their roles and their perceptions, and how they fit together and where they could come to common ground. So the other thing that we learned very rapidly is that any of the questions communities have are really complex. And these questions about the impact of environmental degradation span so many disciplines, and to be able to provide the answers that the communities are looking for really requires building of really broad transdisciplinary teams that can not only work together, but can look for solutions that are different from what any one of them individually would approach. So creating new knowledge as emerging of the goals of each. So the goal was that community involvement would be in all forms and all phases of the work that we did, that it would inform strong team science, that would inform risk reduction strategies that could take the form of clinical interventions, remedial actions, or risk prevention policies. And I think informing policy has been something that has been really fundamental to all of the work that we've done. So we've worked in a lot of communities in the state over the years. And what I want to do, though, is really focus more on the work that we've done on Navajo Nation, because it's the most extensive, the most integrated, the most advanced, and I think tells the story of how we built the program and what the goals and the focus of the program will be, and how other work in other communities has informed this work as well. And I think from this slide, the most important thing to take home is the mining started in 1942, and the last mine closed in 1986. And yet from 1986 until 2003, no health studies were done, in spite of the fact that there were repeated requests to Congress, to the UN, from communities, from Navajo Nation, from Navajo agencies. And in 2000, we were approached for the first time and asked if we could try and help get health studies moving. And that really kicked off the work that you saw represented by the symbols on the title slide. It led to the start of the Dene study, which was the first community partnered R01 level study from NIH that started looking at the health impacts of what at that time were more than 500 abandoned mines with the waste still in communities. There had been work done on the miners and the health effects that the miners had suffered, but the community waste was a much bigger issue that remained for much longer and had no attention at all. In 2010, we were fortunate enough to be able to add a birth cohort study to the work that we had already done on an older generation, and be able to add 2 more generations in the parents and the children, and look at how those exposures were moving transgenerationally, and what was continuing, what maybe had been resolved, but what the long-term impacts might be. And then in 2017, expanding that to the Superfund centers that have really allowed us to look at a lot of the environmental mobility and degradation issues as well. And at the same time, start looking for some innovative solutions that might help to reduce risk. The other thing that we learned, in addition to the fact that no health studies had been done, was the situation we were dealing with was not just in Navajo communities. And what you see on the map at the left, the pink, brown, whatever shading, is the reflection of the density of abandoned hard rock mines in the western states, where 50% of the indigenous population in the country live. There are 160,000 of these abandoned mines, of which, depending on what agency's numbers you listen to, 4,000 to 10,000 of them are abandoned uranium mines. And each of those mines is associated with multiple exposure sources, with waste that was produced by the mines being taken other places, either in the removal of construction debris, in ore hauling during operational phases, or other sources of transfer stations. The indigenous communities that we work with the most are Navajo Nation and Laguna Pueblo, and then in the Northern Plains, Crow and the Cheyenne River Sioux. All of the hash marks on this figure are tribal lands, reservation lands, and the uranium mines that are affecting the communities we work with are shown here with the arrows. The big pink blobs are gold mines, and gold mines are the most prevalent in those 160,000. And if you look at the histograms on the right, the bottom is showing the distance in kilometers from tribal boundaries, and then the number of abandoned mines in the bars. And what you can see is the gold was indeed the most prevalent, but right behind it was uranium along with vanadium. And a lot of these mines started as vanadium mines. Vanadium was used to harden steel, and vanadium is often co-located with uranium. And so when the market for uranium began and the need was driven by the development of the bomb, the vanadium mines were a natural place to look to expand the productivity in mines that were already open. We counted at one point, based on US Census data, which I think most people would agree is an undercount of indigenous population. We counted 600,000 indigenous peoples who live within 10 kilometers of abandoned mine waste. And we worry about that because when you have a culture that relies heavily on the use of natural resources and local resources, and you have 600,000 people living that close to abandoned mines, and you have US EPA alone estimating that 40% of the surface water in the Western US has been contaminated by the waste from those mines, the potential for a higher than expected exposure in those communities is pretty clear. In addition, because the indigenous population has not been included in a lot of the research that drives our best practices for healthcare, that drives the development of our regulatory standards, we don't know if any of the standards or any of the treatments that are in use really are appropriate for the people who are most at risk from these exposures. And in addition to that, most of the reservations, at least historically, have had very marginal infrastructure, especially around drinking water, much less compliance with regulatory standards and tribal systems than you see in the US as a whole. And there's been a substantial amount of research on health disparities that has indicated that this lack of infrastructure is a major contributor as well to disease risk. And so, okay. If we think that 10 kilometers sounds like a really long distance, I just wanted to show some examples from the communities that we work in that indicate it's not really very far at all. And many of the people who are living in these communities are here today, and I really want to thank you for coming. This is Redwater Pond in just north of Gallup, New Mexico. The gray here is the waste from the largest abandoned underground uranium mine in the country, and for a time it was the largest in the world. Depends on how you measure the output. And you can see how close this is to the homes in the valley. In this photo here, we see the grandson of one of our teammates who is watching as 18 inches of soil are removed from around the homes that his friends live in and that in the community that he's played in since he was born. And the valley that drains this is also impacted by another abandoned mine pile on the other side. And when we first went in to start looking at soil concentrations, there were children playing in the sand, the sandy bottom of these washes. There have now been 4 generations that have been raised in the shadow of these mines. And as of today, this mine waste is still present. And the plan to remove it still under debate, I guess would be the kindest way to phrase it. On Crow, the situation is a little bit different. The Bighorn and Little Bighorn River that provide contact with the shallow drinking water wells that serve the communities there are impacted by abandoned uranium mines in the Pryor Mountains. And those are more than 30 miles away from the communities that are impacted and from the water sources that have shown high levels of uranium that exceed drinking water standards. On Cheyenne River Sioux, the Homestead Gold Mine in the Black Hills is more than 150 miles upriver on the Cheyenne River. And that watershed goes along the southern border of the reservation. And what you see here is a band of arsenic that was deposited during the operational phase of this mine that was the largest producing gold mine, the first mine opened by the Hearst family. And this photo was taken, I believe, in 2016, I think. And you can follow this oxidized arsenic deposit all the way down. The depth of it is anywhere from 2 feet to 20 feet on the cut bank of the river. During the time of deposition, the floodplain would carry this arsenic contaminated water more than a mile back into the area that's farmland. There's a riding arena there that is used for practice by little kids until all hours of the night, has riding lights on it, and has arsenic contamination as well. Fish is another major source of food for the tribe, and the fish from the river have great concern for both mercury and for arsenic contamination. So on the left here, we can see our team, including Jose. at Cheyenne River. And this is now work that was done by the Center for Environmental Health Equity during our initial phase. And one of the really inspiring parts of this center has been the ability to bring the 3 tribal communities together to recognize the common impacts and threats to their communities and to work together to look at ways to help solve the situation. And on this particular sampling trip, one of the originators of the YouTube video series Red Talks, which is the Indigenous parallel to TED Talks, did one of the first interviews with us. And I think it's interesting to listen to. One of the things that I think was very emotional for everyone was that some of these communities hadn't gotten along well before. And being there together and looking at the fact that these impacts from outside were impacting all of the communities, and that this was an opportunity to work together to help was something that had a really big impact and a visibly emotional impact on everyone we were working with. The second phase of that center is actually expanding out also to look at the impact of microplastics that are now coming from low temperature combustion of solid waste. Many tribal communities have no solid waste disposal facilities, and burn barrels at an individual level are often used. Those are also low temperature combustion, creating a pretty high concentration of volatile organic contaminants in addition to microplastics, and also very large dump areas that are land waste disposal facilities, but because there is nowhere to take it, often these are also being burned and creating air contamination that moves down many of the valleys. So some of the science that's happening up there now is not only the modeling of where this is going, but using silicon wristbands that have been adopted pretty widely to look at community exposure to volatile organics. And because a lot of the community members didn't want to participate in something like a cohort study, we're able to place those in the community in places that people spend time, in places where wildlife spend time, and get a sense of what kinds of exposure patterns we're seeing and how those compare with what we see in homes as well. So that work is in progress, and we're just getting the first data back that's reflecting and has been really instrumental. We had a fire breakout in one of the sites, and the intensive community dialogue that had gone on around, okay, where would we put these to get a background measure, and where would we put them to get an in-home measure, and where are the schools and where are the sensitive places? That plan was in place when the fire broke out, which meant that within 24 hours, the monitoring network was deployed, and we've been able now to see what the impact was from that unexpected emergency need. This is just a photo of one of the annual meetings from the Center for Environmental Health Research Equity. And I wanted to include this because this meeting was the driver for how we ended up moving to integrating art into the work that we do. And this was a meeting that involved colleagues from Crow and from Cheyenne River Sioux and from Navajo Nation. It was hosted in the community of Blue Gap Tachi and also in Redwater Pond. And you can see everyone talking here over a sheep roast. And one of our external advisors, who's a scientist from Scripps, an immunologist from Scripps, was listening to all the discussion and watching us talking about the work we were doing, and looked out at the room and said, do you really understand what they're saying? And we, of course, thought we had been pretty simple in our graphics and communicating effectively. And all of the heads in the room kind of dropped down for a minute. And I thought, uh-oh. And when people started talking again, they basically said, we love what they're doing, but we don't understand a word they're saying. And it led to one of the best conversations we've had with a lot of laughter and looking for advice on how do we say things better? How do we communicate in a way that makes sense? And what are we missing and what can we do better? And one of the conclusions that came out of that was we're really visual. We think through art, and if you could integrate art into the way you communicate your science, it would be really effective. And this was a pretty timely occurrence because a week after, or a week before that meeting, actually, I had been doing grand rounds at Zuni Pueblo. And is Mallory here? There she is. I was taken by the docs at the hospital into the lobby because they thought I might enjoy seeing the art that was on the walls. So these are just 2 samples. And I was absolutely blown away. These, if you're ever in the area of the hospital, do stop and see them. They're quite large, they're amazing, and they depict many of the physiological systems and were created to help elders understand what they were being asked about in what these physiological systems that they were having symptoms in, how to talk about them and how to understand what the concepts were. And I found out the artist was actually in Albuquerque and actually going through a pre-med program, and asked Mallory if she would work with us as an artist, the initial artist in an artist in residence program, which she accepted. And we haven't recompeted that since then. So Mallory has been with us now for 6 years. And you'll see her art depicted as we go through the rest of these. So any of the work that we do is done in the context of the historical research environment that has affected trying to resolve these problems in the past. So all of the indigenous communities that we work with are sovereign nations. They've had a right to self-governance prior to colonization, prior to contact. The sovereignty extends to sovereignty over data and to protection of the privacy of individual tribal members. The history with researchers has been pretty checkered. For a long time, there was something called helicopter science, where researchers would come in and spend a few weeks and get a bunch of data and leave, and the tribe would never hear anything about it. There was no benefit to the community from that. In addition to that, the treaty rights that protected sovereignty were repeatedly violated by the US government, especially in the face of mineral extraction on tribal lands. As soon as minerals were identified, you can go back and actually one of our review articles talks a lot about the conversations on the floor of Congress that basically said, oh, we didn't know those minerals were there. We're going to have to basically disregard that treaty. And it happened over and over again and has been adjudicated, and the federal government found to be wrong in violating those treaty rights. But that is the history that we're all living with now. And the result of these infringements on sovereignty and the broken treaties led to a lot of substantial environmental and economic injustice. I think the turning point in the sort of perceptions around research really happened with the Havasupai lawsuit against Arizona State University in 1989. They had collected samples under informed consent for work on type 2 diabetes, which the tribe was very interested in. They had a high rate of diabetes. The DNA that was collected for those studies ended up, I've heard 2 stories, one that it ended up in a freezer that was later accessed by other investigators. So the second one was that it was directly given to them. The net result, though, was publication of data on tribal origins, inbreeding, and schizophrenia that was totally beyond the breadth of the consent that was given and totally beyond any discussion or permission of the tribe. In 2004, the Havasupai took a lawsuit that was settled in 2010 against Arizona State University. And the primary focus of that suit was the return of the samples, which they won, as well as the clinic, the school, and a financial award of $700,000. One of our colleagues in 2013 did a survey of IRBs to see what the impact of this decision would be on the future of IRB approval of Indigenous studies, and was shocked to find that the take-home message across the country was the need to make informed consent broader so that we wouldn't run into situations like this where anything could be judged to be beyond the terms of the consent. So the result of all of this had led to a ban or a moratorium on genomic research as a result of the 1989 violation, the creation of tribal IRBs across the country, or council approval of research studies, but a lot more involvement in what kinds of research were done, what the benefit to the tribes had to be, and what the involvement would be going forward. the unintended consequence of that, unfortunately, has also been a further reduction of the inclusion of Indigenous populations in a lot of the research that informs both clinical practice and policy regulatory standards. And that's kind of the point that we come into this, to look at ways that we can help correct that and create a database that is appropriate and that is inclusive of tribal populations. And with ECHO, this great opportunity to not only look at what we see within any individual tribe, but to be able to compare that now with the reactions and the responses that we get with communities across the country. There'll be about 55,000 children, 55,000 to 100,000, depending on how long it stays active. So I want to kind of leave the background and start giving some examples of what we've done, where we started and where we are now. So in 2000, 20 communities on the eastern side of Navajo Nation in the Eastern Agency approached us and asked us to attend a meeting to discuss whether or not we could go after environmental justice funding opportunities that were just starting through NIEHS, and we're very honored to have Dr. Trevor Archer, the new Deputy Director of NIEHS, with us today. They were definitely a pioneer institution on seeing this need and starting these kinds of opportunities. There are two other people that I recognize as being in the room that day: Dareth Watchman-Moore, who is now a trustee for Navajo Nation, and Chris Shuey, who has been involved in all of the work that we've said. We've been very long-standing partners on all of these partnerships. Basically, we spent a long time talking and designing and figuring out how we could move forward. And one of the things that we decided was that we needed to learn from each other. And if we were going to do the research, there was no point in doing it if it wasn't seen as valid. And if it's not recognized as valid in terms of the results that we generate, it was never going to be used to clean up the concerns in the drinking water. And so we spent a couple of months. There were 4 separate sessions with community members talking about what it would require to have the research be valid and be seen as valid, what kinds of analysis, what kinds of involvement, what kinds of questions we needed to know. And in turn, we learned how those questions would have to be asked and how those protocols would have to be developed for us to be able to trust the data that we were getting from the community, for them to feel that it was worth trusting us and giving us that information. And one of my favorite stories from that time was talking with one of the women in the room and her saying that she'd been involved in a lot of research studies, and she always really enjoyed it because it was such a challenge to talk to the researchers and try and figure out what they wanted to know so that she could then make up the right answers to give them. And I thought, oh boy, we definitely don't want to be doing our research that way. So that was a really informative time though. And we were able to develop with the community a series of about 43 questions that they felt we were asking appropriately. We developed a protocol where those questions would be asked by trained community staff. And that was to ensure that we were respecting Navajo cultural processes for building trust and for building understanding. And as a result, we collected 1,300 surveys. I think, is Sarah in here? I think the longest time I remember was 4.5 hours to answer 43 questions. So it was a long process, but it ended up being very effective. We've been able to validate those results by going back over 3 years later and getting virtually identical responses from the test sample on that. And also going back in and validating those original results by looking at medical record reviews and doing follow-up clinical evaluations, looking at biospecimen collection to validate exposure, and then also to go back to the lab and do mechanistic studies to show that we could reproduce the effects that we saw in the field. And what we found in that first study was that the people who had been exposed during the active era of mining, so prior to 1986, they had lived in mining camps, they lived with workers, they would have had relatively high exposures compared to what we see today. And that group did indeed have an increased risk of kidney disease. But what we saw when we looked at the community level exposures, so now a much more chronic exposure, but a much lower dose exposure likely, we saw an increased risk for hypertension as the primary finding. And hypertension is a very high prevalence in Navajo Nation, as is kidney disease and diabetes, and autoimmunity. And in all of these cases, we saw a significant contribution of these exposures to the hypertension and to having multiple chronic diseases, including diabetes, chronic kidney disease, and cardiovascular disease. The autoimmunity, we could also demonstrate a linkage to exposure to uranium through drinking water, and also show that the pattern of the autoantibodies that were being produced were consistent with an environmentally produced autoimmune response and not with one that would be genetic or of unknown origin. And the primary risk factor for the hypertension and the chronic disease, though, remained having proximity to the waste. And we looked at the 100 mines that were in the region of these chapters and weighted them appropriately for each of the households. And then the self-reported activities that brought people into the contact of the waste. And we did this as opposed to biomonitoring because we were really trying to assess a chronic exposure and not just a spot exposure that we might pick up by looking at a urine concentration one time. We were then able to go back to the lab, and my colleague Matt Campen had a wonderful system that was a explant of human coronary endothelial cells. And we could, a graduate student working with Matt and I, was able to incubate the serum from the people who had exposures and an unexposed cohort, part of that cohort as well. And what you could see was an exposure-related increase in pro-inflammatory cytokine production. And this was a response that had already been linked in the literature to cardiovascular disease to atherosclerosis. And so that was a consistent validation of what we had seen in the population results. And then going back a few years later, Katie Zykowski, who's now faculty in the College of Nursing, was able to instill mice with dust from mine waste in Touchy Blue Gap, and then look at the response of the aortas to the normal stimuli that would cause contraction or relaxation, and show that those responses were exaggerated in the mice that had these exposures. So now we could go back and again show a model of hypertension, an animal model that was consistent with what we saw in the population model. And the next step was to do exposures to straight vanadium or straight uranium and show that you could reproduce the same thing. And those also showed the same results. So we now had a model that started from a population study driven by the community, looking at survey responses in a survey that was developed by the community. We were able to validate that with medical record responses, have a high confidence in the data that we got, and go back and show that we could reproduce those reactions in model systems all the way down to identifying a mechanism that would support that conclusion. So looking at could we verify the exposures and what those exposures were to, when we started the first birth cohort study, we began looking at biomonitoring. This was now not looking back in historical exposures as much as looking at current and future exposures. This is a prospective study. And what we saw in that, if we focus on just two of the metals, looking only at uranium and arsenic, which are very prevalent in all of the waste on these Navajo communities that we're working in, what we saw was the uranium concentrations in urine far exceeded what we see in the US population as a whole. If we looked at the NHANES data set, and the NHANES data are collected by CDC and updated on a regular basis to look at a cross-section of exposures that are occurring throughout the US. We had, normally, you would expect 50% of your cohort, if it was looking the same, to exceed the 50th percentile of NHANES, and the 95th percentile, you would expect 5% of your cohort to have higher than that level. And what we saw, you can see in the graphs here, these bars represent the 50th percentile of NHANES. So for uranium, for both women and men, it was greatly shifted to the right. So much higher concentrations. If we look at the 95th percentile, 36% of the dads and 26% of the moms exceeded the 95th percentile. If we looked at arsenic, the numbers were pretty similar. You could pretty much overlay those distributions. The only difference is that the Navajo diet does not contain the dietary sources of organic arsenic that make up a huge percentage of what we're looking at in total arsenic in NHANES. And two of the major contributors are seafood and rice, which are not part of the Navajo diet. And if indeed we go back to the lab and we look at the species of arsenic that we have in our population, we see that it's primarily inorganic arsenic, which is more toxic. We had a few, not a lot, but a few babies at birth. We would collect first urines, and we can see urine above the 95th percentile in some of the babies at birth. And that's not okay in any world. It increased over the first year, and that initial study only allowed us to follow children for 1 year. And the original thought was, gee, maybe it's associated with breastfeeding, that it's not an ongoing exposure. But breastfeeding had the opposite trend. It went down pretty dramatically as soon as kids left the hospital. One thing I also want to point out is the zinc levels. And what we also saw was a pretty serious deficiency in zinc. And the reason this concerned us is that zinc is a nutrient metal and is necessary for normal function of a lot of regulatory proteins. And in fact, a lot of our colleagues had done a lot of work showing that DNA repair enzymes are actually activated by a zinc binding protein. And if you exposed that system to arsenic, arsenic kicks the zinc out, but does not allow the protein to go into the right formation, so it doesn't work anymore. So now you would have the perfect storm in these uranium exposures where you have a radionuclide that breaks DNA, and you have inhibition of the proteins that normally would repair that break. And that meant that we wanted to start thinking about, would this be an opportunity for a clinical trial? And I'll talk more about that as we go forward. Now with ECHO, we have been able to go back and continue to follow up and continue to expand the cohort of kids that we're looking at with the Navajo birth cohort study. And what we see is for both uranium and for arsenic over the first 4 years of life, and these error bars are actually reflecting the fact that in the 3 and 4 year olds, it's a pretty small sample. This is ongoing work, but by age 4, if we look at mom and dad at the time of enrollment and kids by age 4, you can see for both uranium and arsenic that they're starting to look pretty similar, which means these are ongoing exposures and they have not really reduced much from what we were seeing before we started looking at children. So I'm going to shift a little bit now to the metal Superfund centers and look at how we try to understand these exposures and look for points that we can intervene and reduce the exposures. And as I mentioned, the Superfund, the great part of Superfund is that we can now look at the environmental mobility, we can look at the exposures, we can look at a lot of impacts, both at a community level, but also in basic mechanistic studies and organ-specific routes of exposure. And then also consider the remedial actions that might be taken that could reduce the risk in communities. And the 4 communities that are partnering on the Superfund include Laguna Pueblo and 3 chapters of Navajo Nation. And these are the concerns that were brought to us by each of those communities. And you can see agricultural safety is a primary concern in 3 of the communities, but not in all. And likewise, there are other aspects that are of interest in one community or another, but not necessarily across the board. And the center has been adapted to do that. So, you know, what we find in the center will be applicable for everyone. It doesn't mean everyone has to participate in every phase of it. I'm going to focus a lot on the work that has happened in partnership with Touchy Blue Gap. And that's primarily because we have pretty good access there. When we look at Redwater Pond, because that's an active investigation site, it's much harder for us to get access to the waste and look at a lot of these environmental questions. If we look in Tachi, this is a 150-foot wall of waste that was pushed over the side from the top of this mesa and is right across the valley from homes with a community living in proximity to this waste again. The community is very concerned that, number one, the waste still contained contamination and still contained high levels of radiation, and also concerned that water would filter down through that waste and impact through those drainages into the valley where livestock were still drinking the water. Helen Naz, who has worked with us for a long time, and her daughter Serafina, who wrote with us an article to try and explain some of their concerns about drinking water during pregnancy that occurred in many of the families in the community and led to high rates of birth defects. And this is one of the reasons that we were very intent on starting the Navajo birth cohort study, and very pleased that they would share their story so that we could help to highlight the seriousness of this and that we can learn from this as we go forward. So as we were preparing the first Superfund project, we were able to go out into the field and take radiation monitors, look at what the radiation levels were on that waste, see what the proximity to the homes looked like, and also come back to the lab with samples and see what the uranium and vanadium concentrations were, as well as many other metals. I point out the uranium and vanadium because you can see that in the undisturbed soil, they were below detection, and yet in the mine waste, we still had significant concentrations of both metals, verifying the community's concerns. And going back in and looking at the water sources, we were able to go in and sample in the drainages, sample some of the springs that were fed from underneath that pile, and then also looking at some of the ponds that were being used for livestock water. Jose's group was able to publish a nice description of how that arsenic and uranium in the waste was being mobilized and the impact of pH on that process. And we were able to summarize all of this in a white paper, a monograph that was then taken to Navajo Department of Justice and used as the basis for adding this site to the cleanup priority list, which we're extremely happy to see moving forward. And I think this is a really good example of something that was totally community driven. Community participated in the sample collection. The monograph drove a policy change that the community had been trying to push for a number of years with no response. That Gareth is now involved in investigating. So it really is a full circle process, and in addition drove a significant first step in what has become a long series of papers scientifically adding to what we know about how these metals are mobilized. The community also had concerns about windborne metals and what those dust exposures might be. Matt Campen, who's again back in the back of the room and Deputy Director of Superfund, was able to get a loan of a monitoring trailer with an air monitoring station on it and put a series of animals in that trailer for animal exposures to see how that dust coming off the pile would be impacting the community, placing the trailer in between the waste pile and the community. The good news that came out of that was that most of the wind was moving towards the pile rather than away. So that was not going to be a prime exposure source for the community, which could reduce some of the tension around that. But one of the other things that came out of it, two other things that were very important came out of it. And one was that as you started sieving these samples into smaller and smaller size fractions, you saw that the toxic metals were now being concentrated, whereas the crustal metals were at much lower concentrations as you got into the smaller size fraction. And the concern over that is the smaller size fraction is more likely to move in the wind. It's also more likely to deposit deeper in the lungs and lead to a more toxic outcome. Going back to the lab, and this is now a graduate student working in Jose's lab, Sumant Avasarala, who was able to demonstrate, working with Adrian Brearley, that this material had degraded into nanoparticle size, which means that not only is it concentrating, but it is going into a size that is even more likely to be lofted and that we know much less about in terms of the toxicology. And in addition, the mineralogy, so the components that are in those nanoparticles, the types of metals that form them, differed from site to site. We've now looked at this at multiple sites as well. And because of this concern over dust, our colleagues in geography have done some multi-criteria modeling, looking at all of the factors that might influence the mobility of this waste. Remember, this waste has been sitting here since the first mines opened in 1942, and the last mines closed in 1986. So that whole period was a period of deposition. Everything since 1986 has been an opportunity for all of that waste to be redistributed through the communities. There are very few meteorologic stations within the boundaries of Navajo Nation, which makes monitoring and modeling how this dust is moving much more difficult. And so working with the airport monitoring stations on the perimeter and using some of the global data that has been modeled to predict wind movement, our colleague Ian Lin and her graduate students have been able to model predicted dust redistribution and to go back into the data sets that were collected by the federal government to identify areas ripe for uranium exploration. She's been able to cross-validate with that and with some of the data that have been generated by our group in specific communities. And we're now in discussions with Navajo EPA about how these data can be used to, for the first time, look at regulating how land use occurs and negotiating to make sure that people are using land and are given resources to land that is not going to be hazardous to their health. We're now, we've been able to demonstrate with each new set of met data that we can acquire that we can really improve the accuracy of this modeling. And we're poised now to purchase another 3 met stations to target refinement of the model even further, but another good example of how we've been able to move from the science into the policy side. Agriculture is a major concern. I'm going to talk about the livestock studies first. This is work that we're doing in Cove chapter, which was a heavily mined region in just across the New Mexico border into Arizona, northern Arizona. And these yellow sites are abandoned mines in the Cove watershed. This is Joe Hoover, who came up with the idea of let's collar these animals and see where they're going. We have colleagues at northern Arizona that have shown that some of the sheep tissues that they were able to collect did have high concentrations of uranium, especially in some of the organ meat, but they lacked any data on where those animals actually had been grazing. And so we were unable to make predictions on how this material was moving through plants and into the animals. And so US EPA is the trustee for a settlement with the federal government that is now funding the work in Cove chapter in collaboration with Dene College, the tribal college, and with NAU to collar these sheep, goats, and cows and monitor their grazing patterns and see where they're spending their time. We can then gather the forage and we can gather water from the water sources, go back to the lab and test that forage, and we can test the tissue uptake and now be able to finally develop transfer factors so that we can make predictions between the air modeling and this of how this uptake might occur and what the safety of the herds will be. And then plant uptake is obviously the other factor that contributes to the livestock safety, but also to the the plant material itself. And Ileana El-Hayek was able to very nicely demonstrate that calcium is a major control factor, not only in the movement of this material from the rhizosphere into the roots of the plants, but as the concentration of calcium goes up, you also see movement of both uranium and arsenic from the roots up into the shoots, meaning that it is now available as a food source and much more impactful. Likewise, from those pictures that we showed of collecting samples in Cheyenne River, Sherry DeVore was able to come back and do some model studies on those species of plants in the lab and show that fungal communities in the rhizosphere influence the uptake of these metals and the translocation of these metals into plant material as well. And these two findings taken together are now forming the basis for collaboration with Jen Rogers from the Sevieta, working with Jose and Jose's team on, can we turn this into something that will essentially be a bioreactor that we can use to have a novel remediation system for water sources. So that will be tested and in the next phase of the Superfund, which should start in June. So I mentioned the zinc studies and the basic lab work that had preceded them. And several of our team, Dr. David Begay, who is with us, Sarah Atakai, were very instrumental in this, working with Deb McKenzie and with Lori Hudson and Erica Dashner-Titus, who I don't think is here, maybe is on the web, and others on our team to, for about a year and a half, go through community meetings and again, do this multi-directional communication on how do we design a study that would allow this method to be tested to see if it can reduce some of the toxic endpoints that we're seeing. You see in the pictures here, Mallory's artwork depicting the damage to the DNA, the recovery of the DNA in the presence of zinc, restoring normal function, normal immune function of the cell, looking specifically in immune system in this particular case. But through the work with the community, the protocol was redesigned so that these are now longitudinal studies, which was not the original intent, but is going to be a very effective way of looking at the effectiveness of zinc supplementation and bringing a system that was taken out of balance by the removal of uranium from the ground back into balance using another natural metal that can help restore that native system. This is now a registered clinical trial. It started, unfortunately, just before COVID. And so for 2 years, people have been in a holding pattern. We're now back in the field and collecting additional samples. We've learned a lot, though, already. And what you can see here in each of these color codes is a separate individual. These are now 4 different sampling times. And this is the first time we've been able to look at long-term longitudinal biomonitoring to see how these patterns vary. And what you see is that it's not a level exposure pattern and it's not a consistent mixture that we're seeing, that not only the concentrations vary, sometimes you'll see a really high spike, sometimes pretty low levels, but the combinations that you see of uranium on one sampling round versus the next, to arsenic and vanadium in combination also vary. And so these patterns of exposure are much more complex than we thought, which means when we're modeling systems in the lab, we need to think about how to integrate those different patterns of exposure and how those might affect toxicity as well. I also just want to point out that the initial data, and this is still very limited data that we've been able to analyze so far, but it does show increases in serum zinc. It shows a reduction in oxidative stress, which we had identified as related to the metals exposure previously, and it also shows somewhat of a reduction in inflammation. So we're very hopeful as we continue to gather data on this. I want to just briefly also summarize just a couple of the results that we have from the birth cohort study. This has been a strong collaboration since the beginning with Navajo Department of Health, the Indian Health Service. We do all of the recruiting in IHS and PL 638 compact hospitals and have very close relationships with the clinical staff in the hospitals. And I want to thank my colleague Ursula Kanoki Wilson, who is here with us today from Chinle. And several of our research staff who are involved in data collection in this study are also present, and I want to just acknowledge them as well. They've done an amazing job. The addition of this study into the ECHO study has meant that we can now look at impacts on child development in a much broader sense than we were able to do with the original birth cohort study that was very much targeted at the mine waste and uranium in particular. ECHO is looking at environment in a broad definition, including physical stressors, social stressors, cultural stressors, toxicant exposures. And so we'll have a much better idea of what the influences are on overall developmental trajectories on Navajo Nation. And this is one of the reasons that IHS has been so interested in staying involved, and the health boards that we've spoken to have been so interested, because there are no data at this point on normal developmental trajectories on Navajo that can be used to make those decisions on clinical care and what is the appropriate clinical care to treat Navajo children. We have some examples where that has not gone well due to unrecognized sensitivities and differences in development. And we are now able to follow children through age 8, which gives us a much broader window that we can look at the impacts of these early life exposures or transgenerational exposures. And we'll be focusing on pre-peri and postnatal outcomes, as well as respiratory health, obesity, neurodevelopment, and positive child health outcomes as well. The cohort at this point is pretty representative of Navajo Nation. The different colors on these dots represent different phases of the study. The red X's are actually the abandoned mine locations. And you can see that we span both the mining areas and the non-mining communities. We've also been able to look at clustering the metals. I mentioned that there are multiple metals that are involved in this waste, and using clustering methods, what we were able to show, number one, most excited about the 20% that have absolutely no exposure history at all to any of the metals that we've looked at. These are the 11 metals that in the average data for the cohort show higher concentrations than you see in the NHANES data and are also recognized as associated with the waste. What we see though in these two higher clusters is about 45% of the population that is at the high end, and especially this cluster 5. And what we see there is a 3 to 4-fold increase in the rate of preterm birth. And this is very much of concern because in the cohort as a whole, we don't have a really high rate of preterm birth, but we still see a very significant difference between the high exposure and the low exposure. And I know a lot of us are drifting to this third tier down here, which is not significantly higher relative to this one. And that was an unexpected result of a difference in mercury. And we actually are seeing a little bit of a compensatory response when there's a little bit of mercury thrown into the system. Don't know where that's coming from yet, but that is responsible for that difference. And then finally, we are also seeing, and Brandon and Ben are here if there are questions on this. I'm going to let them field them instead of me. But we're seeing evidence of lag in development of language. And this is more pronounced in little boys than it is in little girls. And this is now data collected at around age 4. And this is the result of a pretty extensive diagnostic battery. We have quite a large team of neuropsychiatrists and neuropsychologists that go out into the field and do these assessments. The assessments are done with staff present as well. And so people familiar with Navajo culture sitting in the room and able to observe what is happening. And they're both performance-based and they're also parent report-based. And they look both at the performance and also at the concern raised by the diagnoses or the behaviors that are being noticed. And so what we see, this red arrow is referring to the verbal IQ as assessed by the DAS. And these three green bars in the middle represent the OWL's receptive and expressive language assessment, and then the Vineland communication tool. The Vineland, the DAS and the OWLs are the performance-based instruments, while the Vineland is a parent report of the child's abilities. And so the first thing that we think about when we see a depression in a culture that is not the culture that these tests were normed in is the test effective in that culture? Is it valid to use in that culture? And this is something that we are still struggling to figure out how to assess. We have a little more confidence because our staff have not seen anything in the process of collecting these data that would indicate that people are not understanding the questions that are being asked. As I said, though, we have no prior data on a normal developmental trajectory. And so we fully expect that this could reverse itself when we go back and assess these kids again at age 8 after they start in school. But the parents' report of the behavior and the performance based assessment are pretty consistent with each other, giving us a little more confidence again that what we're seeing is indeed a real phenomenon. However, when we go back and we look at kids that are carrying various diagnoses and we talk with the parents on different instruments, the CBCL and the SRS, we see that there's not a lot of concern about the deficits that have been recognized. And so, you know, this could be indicative of the fact that this is a normal developmental trajectory and we'll see a change. We see, however, the same difference in perception and performance and concern with autism spectrum disorder, which is running about twice the rate that we would expect based on population statistics nationally, and also with global developmental disability diagnosed children. And these are, you know, pretty small numbers at this point, but, you know, something that we are following up on and something that I think we're going to learn a lot from, no matter what the outcome of the repeat tests now that are just starting. The first kids in the cohort have just aged into the 8-year bracket. And I just want to close by highlighting some of the dialogue that we tried really hard to stimulate over the years. For a long time, we've tried to have regular briefings for the trustees. This is from the first trustee that was working on Navajo Nation. This is a subsequent gathering that we had with community members, with US EPA Region 9 that has the lead on the cleanup on Navajo Nation, and with EPA Region 6, which has the lead at Laguna, and the trustees involved in sharing the data that we have. And one of the big things to come out of this is to really try and identify what roles we all play in this process, and to try and reduce concern about conflict and turf wars and who has the right to say what, and make sure that we can, again, going back to that initial diagram, build a conversation where we're all contributing and the contributions of each of the partners is recognized and used to inform decisions. Also going back into the community on a regular basis, and here we have Chris and many of our partners from Blue Gap Tachi building posters that will be going to a scientific meeting. We've now had an opportunity to do this a couple of times. We actually just had College of Pharmacy Research Day yesterday and had many community posters there as well, so that we can spread the word among the people who are doing research on metals, that, you know, the work that you're doing at the bench has real implications for people's lives. And that's been appreciated in the times that we've been able to do that so far. And likewise, the posters have gone back to the communities and been used to inform grazing officials, been used to communicate to tribal council and talk about the concerns in the communities. And then a last point on policy and decisions, we also A few years ago, David came in and said, it's been 20 years since the moratorium on genomics was developed. And if I go back and read it, I see that it was never meant to be a permanent moratorium. It was meant to be a moratorium until we could develop an effective policy to manage it. And the question was, how do you move forward after 20 years? Where do you pick the ball up and where do you start on that process? And so David and I started working with a number of people across the country, both at NIH and at the Tribal Research Office, at the National Congress of American Indians. The UNM Cancer Center agreed to host this, and the Tribal Health Research Office helped to fund it along with NCAI. And for 3 days, we had many Navajo community members. We had 3 medicine associations. We had tribal council members, the IRB. We had the executive branch. We had representatives from NHGRI, as well as Tribal Research Office, and leadership at Navajo Nation, and Indigenous investigators who actually do genomic research and ethical research. And the outcome, I think, surprised everyone, because everybody thought the other group was the one that didn't want to see this move forward. And after 3 days of talking, it became really clear that everybody thought it should move forward, and that there were actually losses that were the result of not being able to look at these data in terms of driving policy and clinical care. But nobody thought that that was going to be easy, because everybody felt that it should be under a policy that was protective, and developing that policy was going to be not an easy lift. A consensus committee was developed and worked for 2 years, came up with the draft policy, which was, the committee was recognized by tribal council. The policy was ready to go to council for a vote. And that month, COVID hit. And so we are still waiting. It is being revived. I've been asked for updates on, opinions on, and many others, on how this should move forward. So we're still waiting to see what the outcome of that will be. And finally, the big data initiatives present the next challenge, I think, for inclusion of tribes in research initiatives. And ECHO is one of those. There are now many of these very large studies that are coming out of NIH. And the intent of Congress and of NIH is that the data that are collected from these will be pooled onto a publicly available platform, and therefore be available to answer many more questions than the ones originally asked. The problem when we talk about Indigenous sovereignty, however, is the data sovereignty is challenged by that kind of approach. And so how to do that respectfully so that tribes can continue to be part of this research that is very helpful in terms of developing clinical care and understanding the risk, and yet not give up the sovereignty that they have maintained for so long. So the Office of the Director at NIH, when we just before we submitted this proposal, actually understood what these issues were and made the commitment that if we got through peer review, the Office of the Director would support the facilitation of a data sharing agreement. And it took 2 years to do that. And Carol can share the pain in that along with many of us. And it was many trips out here and talking with Navajo Department of Justice, Navajo Council, Navajo IRB. There finally is a data sharing agreement. The extant data have been shared to the platform. It's kept on a separate platform. It is not commingled with the other data, and only our research team and the Data Analysis Center, which has control over the data and actually signed the agreement with Navajo Nation, have access to the analyses that are run on this data and the ability to combine those data with other data. We're in the early stages. The first couple of papers that have used the data will be coming out in the next month or so, but we're very hopeful that this will give a roadmap to a path forward that will allow for respectful continued research to answer some major problems and questions that are affecting tribes. So closing with just, we think that community input in planning is a great benefit to all the parties involved. And one size does not fit all. What's worked for us in one community doesn't necessarily work even for our team in another. And we wouldn't want to do a sort of proscriptive model, but I think the general approach is one that has been successful for us and for other investigators across the country. And just acknowledging this is a huge team of people that work in each of these centers. And thanks to all. And I am very honored to have received this award and appreciate the attention of all of you. I felt like it was a very long talk. I unfortunately don't have a timer, so I apologize if I went over.
Thank you very much, Dr. Lewis, for that wonderful talk. We do want to take some time to allow questions from the audience, and I believe we have some questions online as well that we will ask. So if you want to raise your hand if you're here, we'll go ahead and walk the mic to you, and you can ask your question to Dr. Lewis, and then we'll also get to the questions that we have online.
Rebecca Jolly with UNM. I'm curious about some of the factors that you're controlling for when you're looking at developmental outcomes. In a short sentence, that's a big question.
So Bennett looks like he's chomping at the bit to answer here. One of the things I wanted to say is that the ECHO protocol was developed by all of the investigators working together. And if you can imagine a consensus protocol coming out of over 70 investigators working together, you can imagine how big it would get. And we all come from different backgrounds. The only thing we have in common is being PIs of a birth cohort. And so the range of data that are collected are huge. Range is huge, yes. And so we will be able to go back and look at a lot of different variables on that. With respect to the data that we have collected to date, we're going to be going back and looking at a lot of potential risk factors that we have not looked at yet and control factors. So we have the ability to look at all the sociodemographic indicators that might be contributing. We have in the enrollment surveys some questions that are meant to kind of assess degrees of, what am I trying to say? My brain just stopped. Cultural integrity or what's assimilation? Yeah, how much traditional practice people are involved in. I'm sorry, my brain just is totally shorting out here. And so that's one of the things, that we have gone back and looked at. Right now, we're still in that data gathering phase and making sure that we have a sufficient number of participants to be able to start looking at those contributing variables, and we're not quite there yet. I don't know if that answered your question or not, but. And I should also mention that, as these data are collected, there are also possibilities for other investigators to come and ask questions and interrogate that database, either working with us or in the future being able to submit other analysis proposals. Yes. Do you want to add to that?
Something just occurred to me as I was, first of all, thank you. It was a wonderful talk and it wasn't too long. You could have gone on.
You may be in a minority.
It was really, it's amazing what you've done and how important all of this work is to so many different populations, not just to Navajo, but really to children all over the world. I mean, this is transformative, really. And but I hadn't realized that you were collecting data on cattle. Has anybody looked at whether the exposure to the animals has disrupted development in the animals?
We have not, actually. It's interesting that you bring that up because that's something that I was actually just talking to my colleague, John, about looking at cancer development and using animals as a model in that. And it's not a bad idea. Actually, I shouldn't say nobody has looked. The community of Redwater Pond actually has some photographic data of some pretty serious impacts to sheep. And to lambs. And, you know, we do hear that from community members a lot. There's not been a systematic assessment over a whole herd, but there are many instances that people have talked about where they have butchered animals that have had major developmental problems and not lived.
But even things like immunological dysfunction.
Yeah, we have not looked at that in any of the
Their
animals.
development, their life cycle is so much shorter that we might be able to get clues about things to look at in the
Yeah,
longer life cycle.
yeah. No, that's a really good point. And Deb will get on that right away. No, it's a really good idea though, because people, you know, do talk a lot about damage to the animals, and it's a big concern too.
Any other questions? Well, we do have some that were posted via Qualtrics form and on Zoom as well. I have one from Cerl Valdez. The question is, what has been the most valuable experience you've had in collaborating with Native American communities, and how has this experience impacted your life?
I have a feeling I don't want to really ask you to repeat that because everybody's laughing. I didn't understand. If anybody else heard it and can repeat, that would be fine too.
What's been your most valuable experience in working with the Native American communities, and what have you learned?
I think it's the friendship and the here I go again. Being able to have everybody here and to have had these relationships for 30 years is really meaningful, you know, and be trusted. It's been really a fantastic experience, and feel like, you know, the science can actually make a difference. So yeah, I would have to say that is the most important part. All of these people that are in the room.
And this question did
I'm
have
such a wuss about it. Sorry about that.
that question was a two-parter. The second part would be, what has been the most challenging experience with Native American communities, and why is it challenging, and how did you navigate this environment?
Okay, I got challenging experience.
With the Native American communities, and how did you navigate the challenges?
I think probably anybody who has done research on Navajo Nation would say the Navajo IRB, which I have a lot of respect for, but also sometimes it's very difficult to anticipate what will be happening. But, you know, I think through just persistence over many, many years and through the support of a couple of really solid members who could help us to navigate, you know, it's something that we've learned to cope with, and I think they play a very important role. I think one of the hardest challenges is walking into community meetings and somebody who has never come to any meetings before saying that we've never been there. And that's always really frustrating to figure out how you navigate that. But my friends have told me repeatedly that that doesn't just happen to me. So, and it doesn't just happen to outsiders. You know, I think The biggest change probably in my life is learning patience. And that's probably been my definite biggest take home message. It's not something I had much of going. And I have developed a lot more, I think. Vern might argue with that, but he's smirking.
All right, now one of our last questions here on Zoom, actually. So is the largest concern to you exposure the heavy metal toxicity or the radiological risk?
I got heavy metal toxicity.
The greatest risk to uranium exposure, the heavy metal toxicity or the radiological?
The radiologic. We have not looked at the radiologic side of it. Going into this, the belief was that uranium was much more toxic as a metal than it was through its radioactive properties. I think it's something that we really would like to add to the analyses that we have, and it's a big concern that we have. It's a much harder factor for us to assess, but it's something that we're actually looking at and talking with people about how we can add that in as we go forward. Because I think we're definitely at that point.
Great. Thank you again, Dr. Lewis, for a wonderful talk. Thank you for the information and for closing remarks and a presentation from the university. I'd like to introduce our Vice President for Research, Dr. Ellen Fisher.
Okay, I've been told not to move too much, so I'm going to stand right here. I usually move a lot, but since the camera's over here, and I'm not going to spend a lot of time on my closing remarks because I know I'm the only thing standing between you and the refreshments that are down the hallway, and that's always a dangerous place to be. So I did want to personally thank Dr. Lewis for her lecture. It was really fascinating and really truly an exceptional example of the positive impact that our research here at UNM can have on a community or many communities. In my notes, I have a little note to say, mention something about the talk that you were especially struck by. And I was taking notes during the talk and I realized that I was struck by the whole thing. So I can't pull one thing out and say, wow, this is like a really cool thing that I learned from this, because the whole thing was just absolutely phenomenal to me. And I think that some of the things that Johnny said at the end about how the impact on her, this has been 30 years. I would also note that it's 30 years, but it's also just dozens and dozens of people and dozens of trainees who have been involved in this research. And it struck me, she mentioned almost in passing that she did a team science postdoc and that this really was about team science. And that's a topic that's very near and dear to my heart as well. And every single slide that she showed just struck me how when you do team science right, that this is what you end up with is just this just absolutely unimaginable legacy of the work that's being done from basic science all the way to how you have a really truly amazing, transformative and positive impact on a community. I do want to point out, and I feel sort of obligated to do this in some respects, but I'm also really happy to do it, to also note that the UNM strategic planning thing that we've been going process that we've been going through for a while now is going to be officially launched a week from today. And this is another thing that in looking over some of the materials before, I wanted to make a note that there are 5 major goals of the UNM 2040 plan. And again, the work of Dr. Lewis basically fits into all 5 of our goals. And I'll just tell you that those goals are, the first one is to advance New Mexico. I think that she has achieved that. Understand, because that comes with understanding the unique opportunities and needs of our distinctly New Mexican cultures and peoples. The second one is essentially around student success. We want student experience and educational innovation. And again, I would say that given all the students and postdocs and other types of trainees that have been engaged in this, I think she embodies that as well. Inclusive excellence. I cannot think of anybody else who would embody or epitomize inclusive excellence, and as evidenced by the work we've heard tonight. Sustainability, that we want to be sustainable. We want to have a plan for how we can continue to have an impact on our community, to continue to be relevant within what we do. And then the last one is one university. And Jose mentioned that in terms of bridging the Lomas divide. Again, I can't think of anybody who has done that better or more effectively for a longer period of time. So with that, I will just say again that I really thank you for that lecture, and thank you for all your work that you've done. Simply amazing. So let's do one more round of applause for Dr. Lewis on that. And then I'd also like to thank all the members of the Faculty Senate's Research Policy Committee who offered their time to select tonight's lecture, and also the OVPR staff who really did a lot of amazing work in getting this event organized tonight. And now we have an award, we have flowers, we also have a plaque and everything that part comes later. But anyway, to basically recognize and accept this award in recognition of your extraordinary work and contributions to the University of New Mexico. So.
Oh, wow. Look at that.
From our very own Maxwell Museum.
And if you can move forward so you're not in the projector light.
So don't go yet. We'll take this so you don't drop it, but
One more, right? That's right.
one more.
We have one more. Oh my gosh, okay. Here we go. If you would like to
Our amazing artist.
That's so awesome. Here we go. Here we go. Oh, no. Here we go.
Okay, wait, I have to take glasses. Okay, this painting was commissioned in honor. See, now I told you I was gonna cry again.
Do you want me to read it?
Yeah.
Okay. All right. Here's what it says. It says, this painting was commissioned in honor of your love and appreciation for this beautiful landscape. Oh, I'm going to start crying. And your commitment and service to community-based research in partnership with Indigenous communities. Particularly fitting, Spider Woman is a symbol of wisdom, education, and guidance, characteristics which you have brought to all of us at CEHP. Thank you.
Thank you again. Oh, excellent. Please keep them coming.
Oh, so This is, we're from the Redwater Pond Road community, and we appreciate everything that Johnny has done for our community and for all Navajo communities everywhere. And so we wanted to present her not only a gift for her earning this award, but also we know that she's retiring soon. And so we wanted to present her with a gift today as well. So thank you, Johnny.
Thank you.
Oh,
thank you guys.
So just to let everybody know, she was presented with a community shirt. Only the community members have this shirt. So she is officially a community member. And a handkerchief that says "Tletso Toda," also on the shirt as well. And so that means no uranium. So thank you.
Again, thank you all for joining us today in person and virtually. Dr. Lewis, it was an honor to be able to honor you tonight and to hear your talk. We are having a reception for those who are here in person. It is down the hallway in the Stan Commons area, and we have some lovely sweets and appetizers, and also drink and coffee. So please join us for the reception afterwards. And thank you again.